Hey guys, Dr. Brown here with Kubo Math, and tonight we have Calculus 1 differentiation. So we have a problem. The sum of two positive numbers equals 48. Okay, find the smallest possible value of the sum of squares of those two numbers. Wow, what to do here? So let's reread the problem. The sum of two positive numbers is 48. So I'm going to let my numbers be x plus y. So my two positive numbers are x and y, and added together, x plus y equals 48. Now it's saying they want to find the smallest possible value of the sum of the squares of those two numbers. Now if we're looking for minimums and maximums, we know we can write an equation, take the derivative of that equation with respect to the variable of concern, set that equal to 0, solve for the variable, and then perform the first derivative rule to determine if that's a minimum or a maximum. We can confirm that. So that's my plan. Okay? Always have a plan. And that may not work out, but we at least have a plan that we're working relative to. Alright, so find the smallest value of the sum of the squares. So they're saying I'm going to take x and square it plus y squared, and that equals some value here. But I'm going to take the derivative of that with respect to x. All of that, actually I'm going to set that, take the derivative, and I'm going to set it equal to 0, and I'm going to solve for x is what I'm going to do. Now then, if I'm going to look at this with respect to x, I need to get rid of y. Well, what is y? Y equals, if I were to add an x to a negative x to both sides, matter of fact, let me just do that off to the side here. We have x plus y equals 48. So x minus x plus y equals 48 minus x. X minus x, those cancel. So y equals 48 minus x. Now it's critical that you do something, unless you're taking the derivative with respect to y, and then you would say x equals 48 minus y. Actually, I made that mistake earlier, if I'm honest with you. I wrote the equation and had x equals this, but I'm taking the derivative with respect to x, and I end up with an equation with all y's in it. And I'm thinking, oh, what am I doing? Okay, so I thought I would pass that along to you. So we're going to get rid of y by replacing it with 48 minus x. So now we have x squared plus y squared, but y is 48 minus x squared. So that's my y squared. Okay, and I'm going to take the derivative of that with respect to x. Okay, all right, what do we have? Derivative of x squared, bring the 2 down, x to the 2 minus 1, so that's just 2x, plus, oh, we got a chain rule here. We have a outside function and an inside function. You recall where we have f of g of x. So we'll take the derivative of f of x, f of this, the outside function, take that derivative, so it's f of g of x times g prime of x. So we take the derivative of the outside times the derivative of what's going on the inside. So in our case here, 2, we take the derivative of the outside, 2 times 48 minus x to the 2 minus 1, which is just 1, times the derivative of what's going on the inside, which is negative 1. Well, I'm going to take that -1, multiply it right here. So I multiply that -1 times that +2, gave me a -2. All right, so this equals 0. Well, what do we have here? 2x minus -2 times 48 gives me a -96. -2 times -x gives me a +2x. So 2x plus 2x, I have 4x minus 96 equals 0. Now I'm going to put a star beside that because that is my derivative. So d derivative with respect to x equals that. That's, you know, in the first derivative test we're looking at f prime of x. What is f prime? The sign of that when we're looking at different intervals. We'll look at that here in a moment. So if we continue with this, let's add 96 to both sides. So 4x equals 96. It was negative 96 plus 96. Those cancel. Plus 0 plus 96 gives me this. Now I'm going to divide by 4 on both sides. 4 divided by 4 is 1. 1 times x is x. And what is that? 24. Okay, so x equals 24. All right, so what does that mean y equals? Well, y equals 48 minus 24. It's also 24. So x equals 24, y equals 24. Okay, if I square those, if I were to square those, let's see. So now this x squared plus y squared, so I had 24 squared plus 24 squared. And I think that was 24, I forgot what the number was, 6. 4 times 2 is 8, plus 1 is 9. 2 times 4 is 8. 2 times 2 is 2, or excuse me, 4. 6, 17, 576. Okay, so we have 576 plus 576 equals 12, 14, 15, 1, 10, 11. 1152. 12, 14, 15, 10, 11. All right, 1152. All right, so that's what the sum of the squares of the two numbers that we've established by saying that x equals 24, and by doing that y equals 24 also. So the sum of the squares of the two numbers that we found through differentiation here gives us 1152, 1152. Okay. Now then, is that a relative minimum or a maximum? Okay, because the question is, find the smallest. We want to find the minimum. Well, if we said, okay, let's take an interval, a test value, f prime of x sine, and our conclusion. All right, the interval, since we think x equals 24, we could say, well, and these numbers are positive, so x has to be greater than 0. But in our case, let's say it's less than 24. And another interval might be x is greater than 24, but it's less than positive infinity. Okay? Well, our test value here could be 23. So let's let x equal 23. In the test value here, let's let x equal 25. All right. Now then, we're going to plug those back in where I put the star here, because this is our derivative. We have 4x minus 96, and we're going to plug in our 23 and see what we get. So 4 times 23, 12, 8, 9, 92. So we have 92 minus 96. Well, that's a negative, right? All right, I'm not really interested in the value. I just want to know whether it's positive or negative. So what does that mean? That means the function is decreasing. That's what's happening. Okay, now then, let's let x equal 25. Well, 4 times 25 is 100. So 4 times 25 minus 96, so 100 minus 96, well, that's a positive number. So here, what's happening? It's positive. So I know the function is increasing. Well, what does that mean where x equals 24? It's a relative minimum. And that's what we were asked to find. So the smallest possible value of the sum of the squares of those two numbers is 1152. Okay, when x equals 24 and y equals 24. Now then, a person might say, well, okay, let's just challenge that. Let's do that. I didn't plan on doing this, or I would have already multiplied the numbers together, but let's see, let's clear us a spot here to do a little calculating. And you can tell it's humid in here. The board doesn't want to erase very well. Okay, if we said, let's let x equal 23, what does that mean y has to be? Oh, y has to be 25, right? So now it's saying 20, because 23 plus 25, they still have to equal 48. All right, so we have 23 times 23, because we're going to say the square of 23 squared, plus 25 squared. All right, so let's work through this. 3 times 3 is 9. 3 times 2 is 6. 2 times 3 is 6. 2 times 2 is 4. So we'll have 9, 12, 5. 529. 5, well, this one's 529. And then I have 25 times 25. I should know that, but I don't. 5 times 5 is 25. All right, carry the 2. 5 times 2 is 10, 11, 12. 2 times 5 is 10. Carry the 1. 2 times 2 is 4, plus 1 is 5. So that's 5, 2, 6, 625. Okay, so now I have 529 plus 625. So that's 14. Carry the 1, 4, 5, 6, 11. 1154. 1154. So you can see that if we allow x to be 23, y to be 25, they still sum to be 48, but the sum of their squares is not a minimum. Now, if we were to go to this side and say, well, x is 25, what does that mean? Y is 23. I still end up summing the same two numbers here. It's just they're flipped around. So I would get 1154 over here also. So 1152, 1152 is the minimum when x and y equal 24. All right, this was just a simple differentiation problem, but we use various tools. Here we use the first derivative test to confirm. Then we use the sum of two derivative rule here. So good stuff. Okay, why are we doing this? Together we're trying to build a better tomorrow and do that through math. All right, guys, keep studying. That's all for now. Talk to you next time. Thank you.